Here we have a circuit where V is the voltage supply, L is the inductor, and the energy in joules is a half times the value of the inductor times the current intensity squared. We will derive this formula for the energy consumed in the inductor by using techniques from calculus. First we start with P. So the power is the voltage, the product of the voltage times the current intensity. The power, the rate of change is watt per second, is joule per second, so it's watts. So this should be the derivative of energy with respect to time equals V times I. But we know that the voltage on the inductor is L times di dt. So from here we have the derivative of energy with respect to time equals I times L di dt. We have to polish this a little bit. We will have L times I di dt, or we can write this, the derivative of energy with respect to time, L times I prime, where I prime is the derivative of the current intensity with respect to time. So we have reached at this point. We have reached at this point. Now what we need to do is the following. dE equals L I prime dt. dE equals a half L d dt, the derivative of the current intensity squared. I will explain why we write it like this. Now we integrate from 0 to a final value epsilon dt, d epsilon here, half times L, the integral from 0 to t to a final time d dt I squared dt. From here we have epsilon equals a half times L I squared of t from 0 to t. But we assume that the intensity is 0, the current intensity is 0 for t equal to 0, so we have a half times L times I of t, times I of t squared. So epsilon equals a half Li squared.